How many of you remember what was done in the previous class with respect to our properties of addition and multiplication? We discussed the closure property, we discussed the commutative property, and we discussed something called the associative property, right? Rings a bell? Okay. So today,
property also, right?
pardon? Distributive property, yes. So basically today, I told you that we're going to understand properties with respect to subtraction and division. Okay, they're fairly simple, very logical as always. So let's begin. So basically, let me share my screen. So let's not learn individually, let's learn everything in the form of a table again. So we have properties of whole numbers, guys. And today we have our properties of subtraction and we have our properties of division. So again, the first property is nothing else but the closure property. So anyone who would like to speak closure property?
Sir, can I say?
Yeah, sure.
So it's like any whole number minus a whole number is equal to a whole number. So like 5 minus 3 is equal to 2.
Okay. So anyone with any other answers? This was Vamika's answer. And before you guys speak, just tell me what your name is. Otherwise, I'll have to alternate between screen.
So can I speak?
Yeah.
Yes, sir. Closure property is when two whole numbers are subtracted with each other, and the answer is also a whole number.
Okay. Yeah, that's what you and Vamika said. Anyone with any other answers? Anyone with any other answers? Neha, do you have an answer? You remember the closure property of addition. Now, I'm asking you the closure property of subtraction. How is it related? Okay, Saraswati is typing. Let's see what she has to say. Okay. So basically, guys,
Hello, sir.
When there are two whole numbers and we subtract them, we get a whole number. Now, you guys know the set of whole numbers begins from the number 0, 0, 1, 2, and so on and so forth. Now, say we have two whole numbers A and B. A is 4 and B is 2. Now A minus B is 4 minus 2, which is 2, which is a whole number. What Pragya and Vamika have said holds true, makes sense. But what if I reverse it? What if I say A is 2? What if I reverse it in the form of A minus B was 2? What about B minus A? Is B minus A also 2? What is 2 minus?
Sir. It's only applicable if it's addition, it can be true, but if it's subtraction, then it's not true.
Exactly, that is what I was looking for. So basically, in case of the closure property of subtraction, A minus B may or may not be equal to B minus A. In addition, what was the case? A plus B was always equal to B plus A. This was the case always. In any case, it holds true. But in case of subtraction, that wasn't the case. What was the case? It may or may not. Right? That is how we proved it with the help of an example. In the first one, we did A minus B. In the second one, we did B minus A. Properties of whole numbers. Okay. Property of subtraction, property of division. So what was the first property? Closure. Now, what is the closure property in division, guys? Anyone who can?
Sir, whole number are not closed under division, and whole number are closed. Whole number are closed under addition and subtraction, division. and not under subtraction and division.
Okay. Anyone with any other answers?
Sir, I'm not able to hear. Can you please repeat the subtraction?
What? Neha, you had a doubt. So basically, Neha, okay, listen carefully, guys. Closure property of subtraction says that A minus B may or may not be equal to B minus A. Alright, so if I have say two whole numbers, say 4 minus 2, 4 and 2. 4 minus 2 is giving us 2, which is a whole number. But 2 minus 4 is minus 2, which is not a whole number. So basically it is not necessary that A minus B is always equal to B minus A. But over here, if we take a condition, take a case where A is not equal to B always, that is the values of A and B are always different. For example, if they were same, if I had taken 0 and 0, 0 plus 0 is also 0, 0 minus 0 is also 0. That means this case holds true. But what if both are different? So say A is 5 and B is 10. Alright. So 5 minus 10 is giving us minus 5, which is not a whole number. But 10 minus 5 is giving us a plus 5, which is a whole number. So that is what the property says. A minus B and B minus A. What is the relationship? It is not a whole number when they are different, but say A is equal to B, it is a whole number because we are getting 0 in both the cases. But when they are different, we do not get the same answer, as compared to the closure property of addition, where A plus B was always equal to B plus A. Clear? Now, what is the closure property of division, guys? Anyone who can tell me the closure property of division?
So
Yes, speak.
closure property of division is if any two numbers are divided, if any two whole numbers are divided with each other, the answer should also be a whole number.
Okay. Anyone will tell me the answer? Okay.
Sir, it's echoing.
Yeah. Even I am wondering why.
But
Do
can
I-
I also say one thing? Like something different.
Yeah, Vamika, go ahead.
Sir, again in this also, as you said, of course it's like a whole number divided by a whole number is equal to a whole number, but also that we cannot reverse it in this and get the same answer.
Right. And Yashika, I want you to try. I don't want you to be right. I want you to try giving an answer. So guys, now over here, division, obviously. So we are again talking about two whole numbers. Say I take A and B. Now, say the value of A is 5 and the value of B is 4. Now, if I divide A by B, I get a quotient. What is the quotient? What is 5 by 4? 0.8, right? When I divide two whole numbers, the answer over here is not a whole number, correct? But now say A is 6 and B is 3, and you divide A by B. 6 by 3, what is the answer? 2. 2 is a whole number, correct? So basically the property says when we have two whole numbers A and B and one is divided by the other, the resulting quotient may or may not be a whole number. Over here we did not get a whole number, but in the second case we got a whole number basically. And obviously there is a property that will come across where A by B is not equal to B by A in a case where A is not equal to B. Okay, that is something I can explain over here, but let's wait for it. Okay, so right now focus on this. I have two whole numbers, guys, A and B. I took the value of A as 5, I took the value of B as 4. When I divided 5 by 4, I got 0.8. 0.8 is not a whole number. But if I change the values, I took A as 6 and B as 3. And when I divided A by B, I got the value as 2. That is the quotient, which is a whole number, right? So the answer is again may or may not. That is, you have to check. Is the closure property clear, guys? Any doubts with the closure property? Type in if you are clear. Understand the concept? See if you have doubts, only then we move on to the next one. Is it extremely clear? Chalo.
Yes.
Ridhima, Darshil, all of you, we're just 10 of us in the class. I need everyone to be very clear at the end of the class. Okay? I don't want you guys going out with any doubts. Chalo. Okay. Now, property number 2, property of subtraction, property of division. The second property is commutative property. Now, commutative property is something again which is related to our closure property. Remember I told you that A minus B is not equal to B minus A. This is basically our commutative property. What was our closure property in addition? It was when two whole numbers are added, the answer is also a whole number. What was a closure property in subtraction when two whole numbers are subtracted? The answer is not a whole number unless until A and B are both equal. Correct? Please mute yourself. Who is
Sir, I'm not able to hear you. Because of background noise.
okay, please mute yourself. Can you hear me now?
Sir, A multiplied by B is equal to B multiplied by A.
No. I did not even ask a question. I want you to listen to me. Basically, what was the commutative property in addition? The property was A plus B is always equal to B plus A. This was commutative property. It is all, we also just understood this in the previous slide under closure. But the actual closure property is very simple. If I add two whole numbers A and B, the answer is also a whole number in case of addition. But in case of subtraction, what happens? A minus B is not a whole number unless and until A and B are both equal. But now let's look at the commutative property. What was the commutative property in addition? A plus B is equal to B plus A. 2 plus 3 is equal to 3 plus 2. But what about commutative property in case of subtraction? A minus B is not equal to B minus A. For example, A is equal to 3 and A is equal to say 5, B is equal to 3. What is A minus B? 2. What is B minus A? Minus 2. Are both of them equal? No, they are not. As simple as that. This is the commutative property of subtraction. Now guys, who can tell me what the commutative property of division is? Can you tell me a case where A by B is equal to B by A? The property that we are studying is that A by B is not equal to B by A. Is there a case where A by B is equal to B by A? Neha, the question is A by B is not equal to B by A is the commutative property with respect to division. Is there a case where A by B is equal to B by A? When can these two be equal?
Sir, you can add or multiply two whole numbers in any order, but the same is not true for subtraction and division.
Okay, that is right, but that is not my question. My question is, when can this be possible? When A by B be equal to B by A? That is my question. Okay. Listen to me.
Sir, may I please answer?
Yes.
Okay, sir. So what it is, like if you do 1 divided by 1 is equal to 1 divided by 1. If you do 1 also and 0 also, the answer will be like the same. Like in only this game.
This is correct. What about 1 and 0?
Not 1 and 0, 0 and 0.
0 and 0. So exactly. You gave an example. Basically, the logic is simple. In the case where the value of A and B are equal, it can be any value. It can be A equal to 100 and B equal to 100. What is A by B? 100 by 100. Is it equal to B by A? 100 by 100? Yes, it is. So this holds true when A and B are both equal. But if A and B are not equal, then A comma B is not equal to B by A. Sorry, A by B is not equal to B by A. That's what he's saying. For example, A is equal to 5 and say A is equal to 6 and B is equal to 3. What is A by B? 6 by 3. What is B by A? 3 by 6. Sorry. So what is 6 by 3? It is 2. What is 3 by 6? It is 1 by 2. So 2 is not equal to 1 by 2. As simple as that. Is the property of division clear, commutative? Is everyone clear with this? Any doubts before I move on? We have one last property that we have to discuss. Is everyone clear?
Yes, sir.
So the associative property, we won't do the distributive property.
Let me finish associative. Let's see if there is a distributive property firstly. Distributive property is basically split. You can split numbers even in subtraction. -5 can be written as -3, -2 also, right? If we wrote +5 as +3 +2, -5 can be written as -3 -2. So any number being split is distributive, and how you make your calculations easier. So that property can be applied anywhere. But let's look at the changes that are happening. Okay guys, so let's start with the associative property. Chalo. Who can tell me what the associative property is?
So can I tell?
Pragya, your voice is echoing. Mute and unmute yourself. There's a terrible echo.
Now.
Just mute yourself and unmute yourself once, and move any devices that are there.
Okay, sir.
Sir, your voice is also echoing.
Even I have been checking. Give me 1 second. Let me see.
Sir, am I now not echoing?
1 second. 1 second. Yeah, is there an echo now from my end?
Yes, sir. Yes, sir.
No, sir.
Okay, some
It's
of you
okay,
have.
sir.
Is it clear? Okay. So, Pragya, you wanted to speak. What is
Yes,
the
sir.
associative property of subtraction?
The associative property of subtraction is if A into B, if A minus B minus C is equal to C minus B minus A. That is associative property.
This is what you're saying. What I've written on screen.
Yes, sir.
Any brackets that I need to put somewhere?
Yes, sir. The first brackets A and B in the first case and C and B in the second case.
So this is what you're saying is the property.
Yes, sir.
Okay. So now let's take A is equal to 5, B is equal to 3, C equal to 1. Random values. What is A minus B? 5 minus 3 minus 1. What is C? 1. What is B? 3 minus 5. What is 5 minus 3? 2. 2 minus 1. 2 minus 1 is 1. Now 1 minus 3 is minus 2 minus 5, which is minus 7. What is it? Not equal. What did you say? Equal.
But it is not equal because in subtraction, it is not possible that left hand side is equal to the right hand side.
Exactly. So basically, they are not equal. As simple as that. That is the associative property. So what does he say? A minus B minus C is not equal to A minus B minus C. Whatever. When you take 2 as a combination with respect to the third, in the case of subtraction, both of them are not equal. As simple as that. Is that clear, guys? Very simple property. We just have 3 whole numbers over here, A, B and C. Okay? Now,
No, sir. Can you please repeat? It's not. I didn't understand.
okay. Basically, look, the property says A minus B minus C is not equal to B minus C minus A, or say let's have the same order, A minus B minus C. Okay. So what did I do? I just shifted the positioning of the brackets. Okay. This is what the property says, that they are not equal. Now let's take these same values that we have taken earlier. Okay. A is 5. I'm just substituting, nothing else. 5 minus 3 minus 1. He says it is not equal. Let's check. What is A? 5 minus, what is B? 3. What is C? 1. What is 5 minus 3? 2. Minus 1 as it is not equal to 5 minus. What is 3 minus 1? 2. So what is 2 minus 1? 1. Is 1 not equal to 3? Yes, 1 is not equal to 3. Therefore, our property holds true. As simple as that. This is the property, that A minus B minus C is not equal to A minus B minus C when I'm changing the positioning of the brackets. Is this clear? Any doubts here? Someone was not clear. I do not know who had doubt. Yeah, okay. I think it was Neha. ठीक है? Are we clear now?